Visual effects is all about collaboration, so we are doing the same thing here. My colleague John Dickinson came up with a beautiful design for a Japanese horror movie. He really took Sapphire to town on this one. But John is not only a motion graphics wizard. He also studies Japanese, and he wants this symbol on the woman's cheek to be properly scary as well. I think I can help him with that. So I'll be using Silhouette as a plugin inside of After Effects so that I can do all the comp work right inside of the host that John will be using as well for his tutorial. I'm Christoph Zapletal for Boris Effects, and John, let's work together. John wants to heavily lean into the Japanese horror motif for this one, so we'll need to replace the symbol on our talent's cheek with a Japanese kanji for resentment. Let's hide the kanji in my After Effects composition for now, but I'll keep the layer in our comp because I want to take that kanji into the Silhouette plugin as well. I'll apply the plugin to the footage of our talent, and in my effect controls, I can now supply up to 8 additional sources to the plugin. I just need the kanji, so I'll set this up as optional source number 1. If you want to keep all the sources available to be collected at the end, add them to the After Effects composition, visible or not. You can add as many sources as you like straight inside the Silhouette plugin, but they won't be collected. You'll have to do some manual media management, which I don't want to do. Okay, enough babbling, let's open the Silhouette interface. The new project window now wants to know what kind of project I'm actually doing. Well, I'm gonna do a bunch of different stuff to the image, so let's go with comp. That's always a safe choice, and it just gives me a basic layout. Here's my footage already hooked up to the output node, which will return the final composition directly back to After Effects. So I want to start by removing the original symbol from her face. Now we could go about this a couple of ways. The movement is not really crazy, so we could probably use the built-in Mocha planar tracker or something like Power Mesh to stabilize the image, paint on it, and then invert the stabilization. But, thinking a bit ahead here, I'll not only have to take the existing symbol out, but also put the new one in there. So ideally, I do not only want a stabilized image, but an unwrapped texture of a head. That way, we can apply the kanji and then apply the original deformation by rewrapping the texture. And any subtle movement of the skin will also be applied to the kanji. So I'll opt for tracking a mesh of our talent's head using the Headtrack ML feature introduced in Silhouette 2026. But before I get to tracking, let's quickly get another piece of prep work out of the way. The image is not terribly noisy, but enough to potentially cause nasty repeated patterns once I start painting. Also, noise can work against me when tracking the head. If you're looking at this and thinking, what the hell is Christoph talking about? Let me make this a tad more visible. Up here, I'll switch through the different channels. Pro tip: if you want to keep your eyes on the image while switching through the different channels, those are mapped to Alt-R, Alt-G, and Alt-B respectively. Still can't see it? Okay, I will gain the image up really high. Especially here, in the Rec channel, we can now see the noise doing its little dance. Let me bring in Denoise ML. Lovely little fella, which will allow me to denoise the image without analyzing patterns or adjusting curves, because that will all be done by the ML model. I'll just need to decide which model to use. But which one do I want? Okay, let's play back our cranked up red channel again. You see that the noise is not just jumping around, but it's almost moving in clusters in this kind of wobbly way. That tells me that the original footage has either been time warped or compressed. So I'll go with the most recent version of the compression and noise model. Let's do a playback just for a couple of frames. Yeah, that seems to work quite nicely. Before I continue, let's go back to RGB by pressing the white box up here, and let's reset the gain by pressing the square icon here. Now, as you can see, denoise is quite processor heavy. As I know that I'll most likely not touch this denoise again, I'll add a cache node immediately after the denoise. Let it once cache the entire range and then check the Prevent Purge checkbox. So now, once the player has cached everything, it'll be playing back much faster and not create a bottleneck downstream. Okay, let's get to tracking the head. Shuttling through the clip, I reckon I'll start on the last frame and track backwards. It probably will not make that much of a difference, but the face is more in focus and less angled, so that might give the model a better idea of what to look for. The Headtrack ML model is living inside the 3D scene node, so I'll pull that up from here. Up in the toolbar, I'll change to the head option, and now my interface changes a bit. Down here, I get my primary controls for the head tracking. I'll stick with the defaults and just track backwards. Well, that's a bit wobbly, and also, I think the model did not place the mesh exactly where it needs to be. The problem is that I can't really see that much with the black makeup paint down on her chin. So, I'll once again use the gain and maybe also the gamma controls in the viewer. This is just a viewer adjustment, so this will change absolutely nothing about the image I'll send back to After Effects at the end. But yeah, I think now we can all see that this is a bit off. In the object list, I'll select my head mesh, and then over here I'll add a deformer to the head mesh. Now this allows me to set little anchors all over the mesh. These guys can be anywhere on the mesh, they don't necessarily need to be placed on the intersections. I'll place as many as I think I need, but at the same time I'll try to not go overboard with the deformation itself. I'll just nudge everything where it needs to be. So this guy will sit squarely on the piercing, and this one on the corner of her mouth. Also, I'll go through the entire mesh and adjust any area where the mesh is not sitting in place. If possible, I'll place the anchors on parts of the image that are easy to track. Not the hardest task with that much makeup and that many piercings. Okay, all anchors are placed. Let's select them all in the objects list and track them. To do that, I'll turn the track mode from heads to anchors and track away. With the anchors now being actual trackers, our mesh is being subtly deformed by them over time to really stick to our talent's face. The tracking is done by Silhouette's Headtrack ML, which is a really good model to keep these trackers in place. So I won't need to individually babysit these like with traditional point trackers. If you look closely, the tracking is happening in chunks. Silhouette will process a group of frames, take a quick break, and then continue. That's expected behavior. The model is taking a look at a bunch of frames and then is processing that chunk. But now it's done, so let's take a look at the result. Yeah, I think we can work with that. Next up, we want to unwrap the texture of the head in order to be able to paint on it. So I'll grab me an Unwrap node and hook up the output of the Cache node and the data port of the 3D scene node into that guy. That node will then pull all the parts of the mesh onto a flat 2D surface. The more solid the track of our mesh, the less residual movement we do have on the unwrap. This looks good, but I'd like to have this corner sit in there a bit better. But as the 3D scene node and the unwrap are dynamically linked via the data port here, I can just go back, add another couple of anchor points there and track them. With the unwrap done, I'll quickly reset the gain and gamma by pressing those little square icons right to the values. And now I want to paint, so naturally I'll grab a paint node and pipe my unwrap into that. Let's start with some cloning and hey, why can't I paint? Why do I have this little prohibited sign thingy? Well, I'm running Silhouette as a plugin, and everything I've done so far, the denoise, the mesh tracking, the unwrap, will all be saved right in my host application's project file. So, in my case, into my After Effects composition, the one that I'll share with John later on. But Silhouette's paint node saves every single brush stroke. I don't want to bloat the After Effects composition with that. So I'll just need to save the Silhouette project file somewhere so that the software knows where to put all this paint stroke data. Done once, I'll never have to think about this again, but of course I'll have to share that silhouette file with John as well. And now I can paint away. As I said, I'll start with a clone brush and start cloning the skin around that symbol, but I'll use a really soft brush. Also, I'll set the source to output so that silhouette will always clone from the already painted image. Let's see where that gets me. Not bad. Now I'll use the drag brush to blend this in a bit better. And now I'll use the paint node's built-in frequency separation to slightly blur just the color layer. Last but certainly not least, let's record our brush strokes across the entire clip. Silhouette's paint system is really like no other, and if you want to learn much more about it, check out our Silhouette Essentials course on Paint. Katie Morris is an absolute expert at painting, and I'll link her course in the video description. Okay, awesome. This looks really great, and I could add the kanji right now onto the unwrapped image. But let's break this into two separate processes so I've got a bit more flexibility. I'll rewrap the finished paintwork onto our talent's face. For that, I'll pull up a Rewrap node and not connect the gray output here, but rather the pink one here. Why? Well, the gray one will give me the entire image out of the paint node, everything from top left to bottom right, whether I painted on a particular area or not. But actually, I'm just interested in the area where I really did paint, so I'll use the pink output. That will supply the Rewrap node with just the tiles of the image where paint strokes were applied. And look at that, they come with an alpha. Now, the Rewrap node, of course, needs the mesh info as well, so it knows where to rewrap the image to. Let's pipe the data output of the 3DC node into the rewrap, and we can see our painted tiles and our alpha once again wrapped around our head mesh. Let's come that back onto our degrained footage. The big advantage of using the pink paint-only output is that we minimize any unnecessary sampling to our footage. That's also the reason why I wanted to bring on the kanji as a separate process. And it's far simpler than you might think. I'll start with a very simple slab comp. First, I bring in the kanji, then I'll invert it. Now I'll comp that on top of my unwrapped image, but I'll not use the painted version, because I want to use the original symbol as a guideline where to place the kanji. As I said, this is just a slab comp. The actual integration of the kanji onto the skin will happen down here in my main comp stream. Also, I have to keep in mind that the unwrap probably messed with the proportions of the face texture, so the original symbol is a great guide on how much we actually have to squeeze the kanji we are adding. Okay, that should do. Now I want to rewrap just the kanji. I'll pull in another rewrap node, plug in my inverted kanji and then the 3DC node with a head mesh and nothing. The kanji has a smaller resolution than the unwrapped texture, but the fix for this is simple. I'll insert a DOD node here. That will automatically pick up the session space resolution, which was set up when we applied the Silhouette plugin in After Effects by the resolution of the base layer. We need those resolutions matching or we get into a lot of trouble. That resolution's also what Silhouette used for the unwrap, and hence now also our kanji rewrap works. Now the fun bit begins. The tracking is sorted, the retouch is done. Now I can focus on integrating the kanji. I don't know how much of this will be discernible once John applies all his Sapphire magic, but I want to go for more of a tattoo than a makeup look with the kanji. So let's start with a color corrector here, and that will get our rewrapped kanji as a matte input. Put on the master and give this a bit of a petrol tint, just like tattoo ink. Lower the saturation a bit and yeah, there we go. But for a tattoo, this looks way too graphical. I want the ink to bleed into the skin, so I'll need to break up that shape. A bit of blur might help. Yeah, but that's not subtle enough. We need a kind of more elaborate fading effect. Let's branch off another blur here, dial that down, and then use a color corrector to crunch the contrast and the gain a bit. Yeah, but that's still too uniform. I'll bring in a fractal noise and drive up the scale so I get this organic pattern. Now let's use a Math Composite node to bring it on top of our kanji and switch that from add to overlay. Not quite what I expected, but let me check something. Yeah, see that? The fractal noise is creating negative values. I'll put a clamp node here and that should fix the issue. Another Math Composite node set to add will put that on top of my blurred kanji. Let's see that in context. Oh, that doesn't look like what we did up here. Now, a lot of the operations we just added, especially the Math Composite nodes, are modifying the image on the RGB level, but not necessarily on the alpha as well. To fix that, I'll just use a color to alpha node here to send that lovely kanji to the alpha channel. And now my color correction looks like a 20-year-old washed out prison tattoo. So back up here in my node graph, another Math Composite of the inverted kanji will allow me to just style the original back in ever so slightly. And now we are getting to something that looks like a proper tattoo. Looking at this once more, I'm no longer that happy with the way I placed the kanji. Yes, it moves with the skin, yes, the aspect looks alright, but still, it feels like it's slightly off tilt. I could go into the transform node and play with the rotation, but I fear that will not fix my grievance with this. I do like most of the alignment. The corner here is good, and the angle the line down here takes is nice as well. I just want this corner up here to be a little bit higher. The best tool I can think of to fix this for me is the pin warp. I'll pull that in from the warp category, and now I'll start by placing pins on the corners that I don't want to drastically change. So I'll just left-click into the image and create a pin that way. Next, I'll right-click, and in the context menu, I'll turn this pin into a tag. That tag will now just hold this part of the image in place. If you wondered why I placed the pins quite far away from the kanji, that's because I don't want the warping effect to be too harsh. This is still a tattoo on skin, so it should blend in there naturally. So 3 tags are all set. Now for the 4th pin. With that one, I'll just click and drag the pin out. The green circle shows the source position of the pin, and the red one the destination. But I'm flying blind here, so let's take a look at this in context. Enabling and disabling the pin warp, I see something is happening, but not really where I want it. So now I'll use the on-screen controls to nudge this where I really want it. Notice that I can also reposition the tags, and that will change the overall weighing of their influence onto the pin warp. The only thing to keep in mind is to set your viewer control to the color correct here, while the node parameters are set to the pin warp node. So, I showed this version to John, and while he is happy with my work so far, he pointed something out. My retouch killed the specular highlights on the cheek. Let me quickly compare before and after. Yeah, not much to argue there. Let's do a difference map between the old and the new version. Okay, naturally we can see the difference between the different symbols, but it's hard to see where exactly the highlights are supposed to be. So, I'll switch the input from the version with the kanji to just the retouched clean version. This looks much clearer now. So we got these 2 areas where we need to reintroduce some highlights. Of course, I want to piggyback this on the head track we already have as much as possible, so that I don't have to hand animate or track anything on top. The first thing I need to do is to find out where exactly I need to place the specs on the unwrapped image. That's easy. Just as a guide, I'll pipe the alpha of the difference mat into the RGB stream by using an alpha to color node. And now I'll copy the unwrap from here, pipe in the 3DC node via the data port and my little difference map into the image input. Compare that to the original unwrap. This is such a great reference. Now I can very easily bring in a rotor node and use the unwrap as a guide on how much fall off I need exactly where with this mask. To adjust the feather of the individual point, pull out this handle when you've got a point selected. If you can't see that handle, press Alt F to show it. Okay, this should do. Now I can get rid of these nodes as they were only a guide. So now we can rewrap our little speck highlight map and pipe that into a color corrector. I'll just use the master control to brighten this and give it a bit of a warmer tint. Next, I'll blur this a bit. Okay, almost there. I figure the tattooed skin will not be as specular as the brighter skin around it, so let me use an alpha composite node here and subtract the kanji from our specular highlight shapes. The alpha composite node doesn't have an opacity slider, but I'll hijack a matte repair node that I'll insert right here. Now I can adjust the opacity and that way make the color corrector change the kanji a bit less than the surrounding skin. Last thing I need to do before I hand this off to John is to add the grain I removed back on top. But that's easy. Let's head back to Denoise ML and take another look at the node outputs. That pink socket supplies just the original grain the model removed from the image on a neutral 50% gray. We can take that and use a final mouth composite node to put that back on top. Of course, not adding it, but once again we'll use an overlay. Now, switching through the channels a final time, I can see the grain looks exactly as before, only the retouch and the kanji are different. This is a quick and easy fix for adding the grain back in. For more advanced grain management, check out this in-depth video by Elizabeth, linked below in the description. Having a solid head track really made this easy. Of course, you can also use this technique for beauty retouches or de-aging, but I had a blast using it on some more on-the-nose digital makeup. If you want to learn more about Headtrack ML, check out my video on that, linked below. And videos on literally everything else we do you can find in our video library at boriseffects.com. I can't wait to see where John takes this clip with Sapphire in his video. You don't want to miss out on that. I'm Christoph Zapletal for Boris Effects, and I will see you in another video.